Thank you. Did you switch the streaming to the? Yes.
Yeah,
okay.
we are streaming the
Yeah,
Zoom
yeah.
call. Okay, well, thank you for listening. Okay, so we basically what we wanted to do is, apart from playing, is to just talk a bit about the project that David and I have been working on for the last, I think it's 3 years or something. I think we started in 2019 when I had a residency at the at your project, at the ALMAT project. Yeah, maybe we can just talk a bit in general about the project and some of the basic ideas. So the title for this project is Contingency and Synchronization, and it's quite generally concerned with with a certain kind of indeterminacy or openness that can be created in computational systems, or that we kind of search for in computational systems. I think, at least from my point of view, it is really the question, like, can you, with computational systems, with algorithmic systems, create a certain kind of open situation? Can you create something that is really kind of unexpected, but that doesn't rely on, say, pseudo-random number generators or some kind of control in a way, or domestication of indeterminacy or chance in a way. I don't know, David, maybe you want to.
Yeah, I
say
mean,
something
we
about that?
just for you that know, we didn't have prepare a full to say PowerPoint presentation or slides presentation. We will do this in a rather informal way. Yeah, I guess, I mean, our interest is, as Luc said, on discovering or exploring this. I would say some kind of what kind of materiality comes out of this computational processes when we perform them, when we program them, and when we let them encounter, to say, the contingency of each situation which we place them or perform them. We know that, I mean, many of the algorithms or processes we use in computer music are strongly related to computational, to mathematical models, to mathematical ways of thinking, and deterministic models in many respects. We are trying to see how much determinism there is actually, how much indeterminism there is in the translation of these models, in the translation of these mathematical models into computational processes, and how these computational processes develop a contingency or materiality of their own. Yes. Are you agreeing with me, Luc? Maybe not.
No, I I agree with you. I mean, I guess I have a slightly I mean, we come from slightly different angles. So, I mean, almost like, I mean, the title that we gave to this project, Contingency and Synchronization, was a bit like, I mean, I came with contingency and you came with synchronization. And I think we kind of found in the process that there was something really interesting about the kind of determinism and also the teleology of kind of synchronization, which always tries to strive for synchronizing various things, you know, of finding the same frequency or finding the same patterns of things. So there's a kind of tendency towards some kind of commonality, that actually made like contingent events, you know, when we play together like we did now, when something happens, for some event to take effect, can in a way take form to last, to have some kind of lasting impact on what happens. That the kind of that the synchronization algorithms that we've been using really allowed for this kind of contingency to be perceptible in some way, to become something, to have an effect, and to last in some form. And of course, I mean, also to affect each other. I mean, the basic idea, I think, when we play with each other here, as we do in some other constellations of people that attend this Zoom call, is that we try to build instruments that somehow affect each other, and that have a capacity to be affected. And so synchronization is also a way that something from the outside can affect, can change, can transform a computational process, that it is somehow translated into some kind of internal state, and that the outside, whatever the outside is, I mean, that could be a microphone, it could be another player, it could be a human being performing, it could be another algorithm, whatever it is, but that there is some inner rhythm and some kind of outer rhythm, and then there is a kind of response to that. I think that's really a fundamental thing that we have while playing, and that we haven't, we didn't really explain the project very well, or I didn't, but it went through a number of iterations, and some of these iterations have been online sound installations, on-site sound installations, just like purely like non-real-time programs that just run and visualize certain algorithms. And now, like what we're working on now is performing together. So this is actually the last, so far the last iteration of these things. Always using similar kind of systems or similar kind of algorithms, but in a very different format and in a very different material context.
We may maybe send a link now into the chat. It's a link to a page on the research catalog that we have begun. Oh, sorry, this was only for you. Look, to everybody. So yes, it's a page on a research catalog we have begun editing and filling in for the ALMA symposium, which was in 2020. And that page, so to say, makes an overview of many of the things that happened during this project, and of the many facets of that project has, many materials the project worked with. There's, of course, the conceptual level, where we're working with the terms of what contingency is, and what synchronization is from a mathematical and dynamical system point of view. Then there are these equations that you see here floating around, on which our processes of the computational models, computational process that we have programming base in some of the other way. And then there is these iterations here, called iterations. And these are different instances of these works we are working on, and the different that are also happening in different formats. There's this video in the middle of the page, and then there are some other videos regarding our contribution to the symposium we did in Ghent, in the context of the ALMAT project. Then there is an online sound installation in the middle of the page. If you click on it, you get to the page where the installation is running. And so it's a sort of a puzzle, or a collection of fragments. It's very difficult to make sense of it, but I think it gives an idea of of the many layers we're trying to work on during this project, and the many layers we're trying to give justice to while discussing and thinking about it. There is this parts with basically code, the code that exemplifies a few of the models of the computer process we have been working on. There is this code here, which is in the upper right part of the page, which is ARIGA code used to generate the patterns. This code is something that I used in a slightly more complex way, but it's the basis of what I use today to work with Luc. And Re is a programming language that I have been working on mostly during the ALMAT project, a little bit less now. But it's a programming language based on the VM framework. So it's a compiled language. And as you might see, it's a language that has a strong relationship with how differential equations are formulated in mathematics. So it's a very strongly mathematically inclined, so to say, language. So where you have the possibility to define how something evolves in time using differential equations. So using the derivative of a function, a derivative in time of a function, which is this, what it's called, PHI with this asterisk. I don't know how it's called in English, this Hochkommata. This symbol here. You know, Luc?
Single quote.
Sorry, the single quote. Yes, remember, that's it. It's the easier one. That's the single quote notation, which is a common notation in mathematics and physics for notating differential equations. And then you see here in the lower right part of the exposition, there are what we call code flakes. So we have been working not just with one programming language, but multiple of these programming languages. So they have tried to iteratively basically translate these models into different, not only different formats, but also different programming languages. And all of these develop their own particular way of particular feeling or particular materiality due to how different things are formulated, and from how this one thing that interests us is how these formulations develop their own materiality, and how they are not, so to say, isomorphic functions of what one tries to program. Each of those have different evolve different textures and different materials. Yeah, indeed. So there is, I think the first one is in this figure. The first one is it's Elm, right?
The top one is Elm, yes.
Yeah, the top one is Elm, which is a part of the code that Luc used to develop this small little online installation you see right on the left of it. So if you click render in that page, you will see something is generated.
And you can change the that was actually I think the first thing that we did.
It was the very first thing that we did. Yes.
So you can experiment with coupling of these Kuramoto systems and various parameters that you see there, and also different ways of coupling them to the neighbors, to everyone, to all of the others, and so on. And I think that gave us a kind of a first intuition. I think a kind of visual impression can be quite useful there. And then the second one.
The second one is Fortran, which is a language that sometimes I use. I learned this during my studies in physics, and it somehow remained attached to me. I know it's not the most beautiful language, but I like it. The third one is again Henri, that's language that I developed. The fourth is, I guess, Haskell.
Yes, that's
Yeah.
Haskell.
Yeah.
That was, I think, another kind of visualization that we didn't really use very much, but it was another implementation of that system. Yeah.
Yeah. And the last one is a piece out from a C, basically.
Yeah.
It's from a UGen that we have coded for SuperCollider. And all of these bits of code basically try to realize or are slight variations of this model that Luc already mentioned, the Kuramoto model, which is in the center basically of the page, center right of the page. You find a small paragraph called the Kuramoto model. At the end of it, there's the mathematical formulation of that, and that mathematical formulation we have translated into different programs, and that translations you see there in these figures. The Kuramoto model is one of the very first models that Dynamical Systems formulated mathematically, that tried to formulate what happens when oscillating entities interact with each other. And you can imagine this. I think one of the things that Kuramoto was thinking of when he was formulating this system is, for instance, cicadas that communicate to each other. So cicadas have produced their own rhythm, but at the same time they interact with all the other cicadas in their environment and adapt their rhythm accordingly. So you see there, it's a very simple and elegant formulation actually. So you see there is this phi dot. The over dot notation means now is the derivative in time of the phase of an oscillator. The f is a constant frequency, and then there is this part here, which is the coupling part. Basically, it's the part describing the interaction, where you see there is a sum over all elements in the system, over all entities in the system, of the signs of the difference of the phases of each of these entities. And this is, of course, makes this coupling part makes the whole system nonlinear, which makes it particularly interesting for the study of chaotic system, because it tends to be chaotic, even if there are regions of the strength. I mean, what you can variate in this model is the strength of the coupling. So, meaning how strongly each cicada will respond to the variations of all other cicadas in the system, and the strength changes dramatically how that system behaves. It may it may change from something that has a very strong telos towards a synchronizing rhythm to something that has a very, very that evolves in very different rhythms with different frequencies overlapping and overlaying different rhythms, and and developing in very different ways. So it's a very simple formulation, but yet it contains a very powerful or a very variegated behaviors in it. And I think this is one of the things that is at the core of what interests us. So how this very simple, compact formulations develop materiality that are so different and that are qualitatively almost in non-comparable. I talked a lot maybe now to the Luc Döbereiner.
Um, yeah, maybe I can just say a bit about the system that I used in what we just heard. Um, so basically, I think one of the fundamental motivations for the kind of system that I've been developing for the last 3 years, which is sort of a general digital synthesis system in a way, was that I felt kind of in a way limited, or I felt like two things being an obstacle in my usage, primarily of Super Collider as a platform, and that was on the one hand the kind of the way that you can represent graphs of like networks of processes. That I ended up always basically generating feedback systems that had were essentially one big loop somehow. And that I found it very hard to express graph structures that are more complex than that, with many interacting components that could be very simple components actually, but where the complexity is more a result of the interaction of many simple components rather than a few complex components that are connected like in one loop or something like that. And I was also quite interested in the graph as a kind of data structure. Like what happens if we do like whatever, typical graph construction or traversal or manipulation, transformation algorithms. How can we change like synthesis networks like that to see the kind of the flow of data in a graph as the main material in a way. So this was so cumbersome and difficult to write in Super Collider. I always ended up basically writing one gigantic synth-def in which to do this, or I would just write everything in C and then just load it as a Eugen, and then it didn't really matter that I was using Super Collider at all, because I basically just ended up writing a C program. So what I did quite basically was I used Rust, that programming language, because it allows you can express like complex data structures in a very nice way. In a way, you have all these. It's very strictly typed, and you have a compiler and so on that helps you to express these kinds of things, complex data structures. And at the same time, the performance is very good, so you can use it for audio synthesis. And I built a system around an existing library for expressing graph data structures. But as kind of nodes in the system, you have something that is similar to a Eugen in Super Collider. And the other that is the one motivation basically, and the other one was that I also wanted to get away from code in a way while playing. I know that you can do that obviously with Super Collider or any other environment as well, but I was always like, I actually wanted to get away from something like live coding, and wanted not to see the code. In some sense, I've never really used something like Max or PD, but the idea of like throwing something in, maybe like the way you work with a modular synthesizer or something like that, where you have things, you put them in, and you work on a different level while playing rather than developing the things. I think that was actually something that was kind of new for me, because I had always wanted to actually join the things. But I think for the first time with this system, I kind of saw this as two different things, developing a system and performing with it. So it's very far away from live coding. I program the things, so it consists of two programs basically, the synthesis server and the front end that's written in Elm. And then the front end which is quite graphical, which visualizes the graph basically of synthesis elements. Is what I use for playing with it. And then obviously I was trying to find constellations of processes that synchronize or that can be affected in some way by what comes into it. And that's also what I'm interested in while playing. When playing with David now, I'm kind of searching for situations. I'm also throwing in things. I'm basically, most of the time, I'm concerned with changing the weights of the edges in that graph. So how strong the connections between certain things are. So how strong is the connection between what comes into the processes that are running, but also how strong are the connections between the different constituent elements in there. And these elements are, for example, Kuramoto oscillators. There's some other nonlinear oscillators, like these kind of Chua or Van der Pol oscillators, and a few other like much more simple processes in a way. And yeah, so I'm still very much concerned with seeing that whole synthesis graph as a thing that I manipulate while playing live. So to be able to take things out, take things in, put things in, change the weight, change the types of connections that are there, and see that whole thing as this sort of as something that is in flux, as that kind of computation of things flowing around that is in flux and that I shape while it's running. And it is a situation in which I am not totally in control. It's this element of contingency is something we embrace, and that is really a basic motivation for this whole thing. So I'm also interested in the situations where I don't really know what's going to happen when I put something in, when I change a parameter. I'm not really able to really plan any kind of action. So the intent, there's always a problem somehow with my intention and the outcome, which I find motivates the whole thing for me, or makes it interesting really. Yeah, now I talked a lot. Maybe we can we can open it up for questions and discussion. Are there any questions, discussions?
I have a question. It's interesting, I think, this strong connection that you show on the research catalog and also today between the visual and the auditive somehow, that you exploit the same algorithms and do things in 2 dimensions or 1 dimensional. And I wonder if you could speak a little bit about that, how this materiality of the models, or the materiality of the contingency of these sort of decisions, how they manifest visually and in the sonorous, and how you what's the connection there, and how do you see those two things in this project? Are they sort of parallel, or are they informing each other? And also, if you could say something about the visualization that you use today.
Yeah, maybe I start with the last point. So the visualization we used today was a recurrence plot of David's and my output. So basically, it's one channel of each of us, and it's basically a 2-dimensional plot of differences. So that allows us to see if they are, or what it visualizes is really if they are like common patterns or things that reoccur also in time So it's in some sense it kind of we could say how they correlate the signals in some way. It's visualized like this, and it's in a way you could say a sort of technical way of inspecting a system, but we use it. I mean, I have to say, while performing, this is almost my primary sort of feedback. I don't look at any slider values. I just look at the visualizations and I listen to the outcome. So it is for me something that tells me something about also how close we are. Like if there are certain patterns that form, things that are stable in there, I see it tells me something about the coupling that we have. So this is so in that sense, for me, it's part of the instrument. When we play, it definitely changes my my way of performing. And then, I mean, more generally, I think we started with visualizations because it gave us, like, kind of, as I said at the beginning, a certain intuition about how processes can behave, like on a different, maybe on a different scale than kind of sonification or audio things can give you. I don't know, David, if you have another view on this.
I think it's right. I mean, I think we have. I mean, all these visualizations that you see there are more or less technical. How you said it previously, Luke. They're more or less technical ways of looking at these systems. They are not something that we came up for. I mean, we have worked with another kind of visualization also for this kind of iteration we are doing now, which uses basically Lissajous figures for visualizing how our two signals behave to each other. So also all these things are kind of known techniques to inspect signals in some way, and of course there is a sort of a artistic touch to it, or we try. We're not visual artists, of course. It's not our primary medium, but we still are not trying to just look at the parameters, so to say, or just look at the numbers of our MIDI controllers or whatever we're using. We're trying to grasp how the system behaves, and that is, of course, something that has a lot of parameters, a lot of dimensions that cannot be really captured easily. Cannot be really captured by just looking at parameters. Of course, the sound gives us the most information, but having another channel is an interesting complementary material. I think we've begun using this kind of visualizations mostly as a technical help for us to understand or have another kind of a feeling how the systems behave. At another time scale, of course, and also at another dimension. I mean, you see there is an experiment with a two-dimensional system, and this was for us a way to see, well, what happens if we do this with more dimensions, and we see that there is a completely different way to organize and to synchronize in the system, and this is not something that is not known mathematically or in the study of dynamical systems, but it was a nice moment to see, oh, we can do that actually, and we can see that, and we can really easily work with the parameters and completely change what comes out of it. So it gives us a different kind of feeling of the things if we use them as they are or not. It gives us a sort of not necessarily mathematical understanding, but a sort of an aesthetic understanding of that, of what the process does.
Yeah, just to add to this, like something that, as you said, we are not really visual artists, or even like people that think very visually, I think. either of us, but I think it's a different kind of way of engaging with it. Like a sound, at least to me, is always something much more immersive, something that you are, I mean, obviously it's something you have to temporarily be sort of coexist with the sound. You cannot easily fast forward or, skim it in some sense. So there's something more external to me, to visual things that aren't quite, it's just simply not as sort of immersive. Not to say it's more objective, it is not more objective, but it is sort of more external in a way. I don't know if it makes sense to anyone, but that's how I feel.
And it has also a completely different time temporality, necessarily, of course, which is interesting because it forces also to take a different step and take a step back, so to say, in some sense. I think Daniela had a question.
There's also Casper and Juan are also raising their hands, but
I think Daniela was before.
Okay. Yeah, but I hear myself, So, my question was going a bit in the same direction, and I don't know how to express it yet completely, but I think there is a sort of, or I perceived an aesthetic quality both in the sound and in the visual part, which somehow make the two blend in a way that makes it perceived like really as a unity. I don't know. It's maybe the visual part. What comes to my mind is the term analog, because it has this kind of old television flavor, so to say. And I was wondering whether you see this as something that comes at the end of the process of composing, like how the two systems interact, or are you also playing with the visualization while you are playing with the music?
I mean, the visualization was running here on my machine, so I was playing a bit with visualization while we were playing. I mean, there were these situations in which I think there was a lot of DC or something, like it was just white for a couple of times because it was somehow kind of saturated, and that triggered me. Like, I was thinking, should I change this? I have like 4 parameters I can change on the visualization, and I did change it a bit in response to what happened there. But I also thought that was an interesting moment, this white, that was really just white and there was no difference anymore in the visualization, whatever we did. But then, so I didn't do very much, but I did at a couple of moments interact with that. Maybe just another thought that came up when you asked your question, I don't know if it answers anything, but was that like in the kind of limited material that we have, we kind of try to find always sort of new constellations, new situations in which things can be coupled in a different way, or patterns emerge in a way that we hadn't really foreseen. And I think that this is also something that happens visually, that like if we are in a new situation, there's also going to be a new visual pattern somehow. That's how I feel it somehow. That there's a kind of surprise. Oh, it can also go into this thing, and even with that like grayscale-y, as you say, analog, very limited kind of thing, there can still be like always a new thing that you discover somehow. That's how I saw that. David, do you want to say something, or should we maybe take Casper and Juan, who have been waiting for?
Yeah, I think we can I don't know who was before. I can't remember anything.
Doesn't matter. Let's go with Casper here. He's
Yeah.
to the left.
Yeah, so thank you. So I have a short and a maybe longer question. So my short question is were your systems interacting only through sound or also through a different medium?
No, only sound.
Only sound, yeah. So okay, yeah, I guess.
Well, they were actually interacting like only through data. I mean, through numerically in a way. I mean, it isn't.
Yeah, okay. There's not really sound there. Yeah.
No, I mean, not really. I mean,
Yeah.
it depends what you if you consider that sound. But
Yeah.
yeah.
No, I find it quite interesting that you have, in a way, a very spatial, or at least, I mean, as soon as you're dealing with nodes of networks or this type of thing, it becomes a kind of spatial thing, which is often not so important in sound or even synthesis, where it's more maybe, I mean, if you look at the naive things like, I don't know, logic or whatever, it's mostly like chains of things after each other. Maybe there might be some loops, but it seems that you have been going into something much more spatial. And I mean, have you found anything like, I mean, to maybe, I mean, have you found anything useful in these abstractions that you can have on node networks? Maybe like how connected the thing is, or maybe if there's islands, or maybe even the topology of it, if there's holes in it in some way, or I mean, I guess there's a lot of exciting mathematics you could get lost in, but
Yeah, yeah. Yeah, I mean, I did. I mean, when I manipulate, there's like certain kind of constraints. Like there has to be, I forget the mathematical lingo somehow, but it has to stay connected. Like there's a kind of um, basic constraint in the system that you cannot have islands basically that are not connected to each other. There has to be a path from everything to everything in some way. So when and that there's all sorts of small constraints like that, you know, the number of inputs a process sort of requires and the number of outputs it has, and everyone is maybe slightly different, and if you add this all together, it's already quite complex, like the kind of constraints that the system has. So but this is actually just taken care of by the thing itself. I don't really deal with it. I just kind of childishly throw something in there, and it's all like taken care of by that system. Or I mean, I can randomize it. I can create a circle, so kind of pull it apart and make a circular connection. So to have one big loop and then start to create like kind of more like small world networks. So where you have a lot of connections in a certain regions, but then very few that go outwards to another of these strongly connected areas. So yeah, I do play with this kind of graph level stuff, and but the simpler the processes, I guess, the more of that really plays a role.
because I guess it can escape into some kind of noise where there's little influence anymore. It
Yeah.
just kind of there's catastrophe in a way, where it just becomes chaos or total
Yeah.
Well, that's maybe a difference. I mean, towards what is something that comes into my mind very often. I mean, what in physics or mathematics would be a catastrophe is for us very interesting. Uh, Noise is something that is for me very interesting, and how to get into and out of it. This is something that probably no mathematician nor serious physicians would care of, but this is for me. It's part of the regions where it gets really interesting, and of course, I mean, I can probably we think in of space in a very different manner, Luke and me. But of course, the for me, all this, when I'm writing or when I'm coding these systems, for me these systems have all space. Is all spaces. When you're studying this mathematically or physically, you start with let's put this thing into a subspace. This is the first thing you do in order to understand something. You construct a space around it. And one of the very first things I did when trying entrainment systems or synchronizing systems out was go into the cube, which is the place I'm sitting in here now, which has 12 channels, 12 loudspeakers in a ring and in the lower ring, and put one of these Kuramoto oscillators, just making tick, 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 tick metronome, on each of these channels, and then start experimenting when I switch on the coupling a little bit, or if it is a lot, or if it is little, and if it is a lot of it's a very high frequency with a very small coupling, and this makes a space out of behavior, out of temporal evolution, which is something that for me is extremely interesting. So this is probably another kind of space to, with respect to what Luc was talking about. But I'm very much interested in this. What space is created by temporal differences and temporal evolution, and what kind of space emerges from desynchronizing and synchronizing. I mean, in this respect, synchronization is maybe the least interesting point for us. It's more when things are not really we're trying to synchronize but not really catching it, not really getting to it. So what kind of space is there, and how can we control how this emerges slowly, if this can be slow or fast? Um, Something is broken.
No, we can hear you. Your image is frozen, but
Yeah, I could hear it also.
Juan, maybe?
Yeah, hi. Thank you for the presentation, really interesting. So you mentioned that each of these, there's some feedback. Oh yeah.
Sorry, I was back. I'm back. Can you hear me now?
Weird.
We can hear you, yeah.
Okay, sorry. I don't know what happened, but
Yeah, anyway. So you mentioned that each of these iterations can happen on what I understood as some sort of different temporal contexts. Some of them can be performative, so I assume you're controlling them in real time, and some others are in the form of an installation, which I assume it's a sort of an open form, and you just leave it working. And so I was thinking, how do you conceive these sort of different temporal contexts, and is there any sort of, because then at some point, if you're just letting the algorithm to flow without any control, or maybe you have a strategy for controlling it, I don't know, you have some sort of main kind of like a you would say like a main temporal controller which feeds it with different data at some point, and you have some, you know, kind of a temporal strategy for that. So I was wondering if you could maybe talk a little bit about that.
Mm-hmm. So yeah, maybe it's a great question. Maybe I can just describe a bit the installation, the kind of on-site physical installation that we made that was shown in Ghent at the Orpheus Institute, I think in 2020 or 2019, I don't remember, just before COVID, I think. And so these are, in that installation, there are 6 oscillators that are played back over 6 loudspeakers, and they are fed the input of 6 microphones. So each oscillator has basically an output, which is a loudspeaker, and an input, which is a microphone. And these are placed in the space, and they're not these Kuramoto models. It's another kind of oscillator, but they also try to synchronize. And they play kind of pulses, and so these pulses are sort of spatialized, and they create these regions where they sort of stabilize and they get into patterns, and it's very spatial because it depends on the distance in space, because of the time delays, obviously. and it depends on how close the microphones are to the loudspeakers and so on. So you have a kind of spatialized temporality, and then when people move around, and if you create noise, which you inevitably are going to do in some form, or if there's some outside interference, then the thing gets kind of disturbed. And it loses track because it maybe synchronizes with something else, or it tries to synchronize with a sound that a visitor makes. And then that propagates through the system, and it gets kind of shaken up, and it may settle down into another semi-stable state, but it's never really completely stable. So there is something, I think, again, very spatial about the temporality. You also, when you move around, you see it always from different perspectives and different voices of these, if we think of them as kind of voices, these six oscillators become differently, have a different importance depending on where you are in the space, obviously, or become like the kind of rhythmic grid that you use to understand all the other voices, and that changes. So I think there is something about the temporality that's very connected to the space and very much connected to this kind of experience of exploring and walking around there. And that's also something we try to transfer into the online installations in some form, which are also influenced by the microphones of the listeners and so on. So I think that's very different from how we perform, like if we talk about temporality, or even like something like musical form or something like that, in the and I think that's also different probably because when we play now, as we perform now, we use two completely different systems. I don't really know David's system, and he doesn't really know what I'm doing. So it's not really one sort of homogeneous thing that creates this space and time, and that's the whole situation that we develop, like in the installations. But it's like two instruments that kind of merge, sometimes split apart, and at least for me, it's more of a kind of reaction, listening, trying to find settings in which the system is responsible in time, in which it picks up certain patterns, and in which it picks up different type of different time scales, basically, where it syncs like on a kind of timbre level to something that comes from David's system, but also maybe on a rhythmical and possibly even on a kind of phrasing or formal level, and does something with that. I think that at least that's what I'm kind of trying to find. But there's of course also me fiddling around with it, trying to find these settings, which is like another temporal scale in there. Yeah, I don't know, David, if you have.
No, I guess it's very much the same for me. I mean, I'm especially with this duo, I'm trying really to get in another time scale, listening time scale. So what I'm trying to do is basically similar as Luc described it, but I'm using one system which is basically made of a lot of those Kuramoto oscillators, all interacting with each other and strongly coupled with the Luc's signal. And what I'm trying to do is to get, at least at the beginning of the performance, very quickly to a very strongly correlated situation, and then mostly don't do anything else. And which is something I like, or do very little, as little as possible, which is something that I like very much, because it's not very often that you have the chance to listen so well to what you are doing, or listen. It's another kind of listening. Of course, it's not listening well or less, or less well, but it's another kind of listening which I really enjoy in this kind of situation. And still, it creates these systems, or the way they are coupled together, or the strength they are trying, or the ways which they are coupled. It produces such a rich repertoire of changing phrases and rhythms, and sometimes I'm just trying to calm it down a little bit because it's maybe too much, or try to mostly slow down the way in which it goes from one situation to the other one, and I like that very much. Instead of being active in doing things or trying to generate things, through listening, trying to reduce things even more, is something that I like a lot. But mostly, I'm trying to get in the situation that I'm just listening. Just try to do as little as possible, which is always too much probably, but I'm trying, but I think it works really well with this kind of coupled systems. It gives really this the possibility to really step away a moment and just listen. It really evolves into regions that one would not otherwise find if would one would continuously turn on the knobs, probably.
Maybe you could try making an interface that kind of limits the amount of how fast you can control it or something, that you run out of moves, kind of gamified version of it. So to see how much you can limit yourself.
Well, I have already, I'm using this kind of thing here, which is just knobs. And I'm using it as a second order controller. So I'm not using it as a direct control of parameters. I'm just being able to control how quickly one parameter goes in one direction or the other direction. That's it, which makes it almost impossible to stop something, but it is but it is part of it. So the controller basically is another dynamical system that I'm trying to cope with, or not, or just letting do it. So what is good about it is that it can send something to on a path which can take very long to get to, and
yeah, as a listener, I really got the feeling of a kind of traveling or moving through some kind of very large space. So I constantly felt drifting, although, yeah. So I think that worked somehow. That was very clear from listening to it.
I think also in this case, it's something good. I mean, this kind of control is then almost impossible to control, and which is a situation I put myself into purposefully. This is something I do sometimes. Put myself in dire spaces, and then lament how dire those are. No, but and at a certain point, I really gave up, and really, okay, if I cannot really control, then I have just to listen to it, and it works basically very well for me, at least at the moment. Yeah.
Gerhard?
I don't really have a question, but maybe just a comment in that, because Caspar started talking about how he experienced your performance, and what I really liked about it was the fact, or that was this the relationship between the periodic and aperiodic aspects of the sound and the structure on top of it, and on all levels. So that is something that's really working out very well, and is very inspiring to listen to. I had trouble to sort of watch the visualization during the whole time. So for longer stretches, I was just closing my eyes, because it was kind of difficult to cope with both at the same time. And I find it also quite interesting because I guess there's much more, under quotes, information in the sound, right, than in the image. But still, the image sort of overloaded my capacity to listen. So that was the other aspect I just wanted to share with you.
Yeah, I think I can relate to that. I mean, I also sometimes just turn away from it and then don't look at it. Sometimes it's too much.
I mean, I understand when you use it as a monitoring tool of the structure, you are of course in a completely different state, right?
Yeah.
But I was just, I was switching on off the other monitor, and I just had this one full screen representation of the image, and then I was asking myself what would happen if that was projected on a large screen, right?
Yeah.
Would it, I don't know if it would be, but it's also very intriguing, of course, to see what happens visually and sonically. And sometimes I was under the impression that there were some premonitions of the visualization. So I was wondering how in sync it actually was. There were certain things that seemed to appear earlier in the image, but then of course there's the whole streaming setup that is behind your
should be quite
system.
in sync actually.
Okay, so the idea is that it should be
It should be because they both were streamed from the same location, so should.
I mean, it didn't matter whatsoever. I just noticed at some point that there was
I think it's like retrospectively we also attribute a lot of meaning to the visualization that it hasn't really had at the time. But because there's always this you try to find the way that they correlate somehow. You try to kind of make it the cause or make it the consequence of the sound.
Yeah, and maybe that's also what is so sort of demanding mentally if you watch it and listen at the same time. Right? Because I notice when I close my eyes, I'm just like, it's just the sound.
But you can always close your eyes. We are not.
That's
we are not installing any Clockwork Orange devices. I think Nina is raising her hand.
Yes. Okay, I'll try to put the video on. I'm from home. I'm using hotspot, so I don't. Okay, there it is. Yeah. So hello. So I'm not high. I'm using hotspot, so it's a bit difficult at the moment. But when it came to visualization, I actually was quite interesting what you mentioned there. Thanks for the great performance, because in essence it is. I felt like I'm in the movies and at the same time trying to synchronize and try to find meaning in the visualization together with the sound. And I also almost traveled it back in time to the time of TV and radio and trying to look for that synchronicity of the sound and what I'm looking at. So in essence, it's quite interesting because how could you actually, if there was nothing there, what would that something then be? Because now you're visualizing, it is visual, even if it's not intentional. There is some kind of message that is brought through that visualization. But how could it be, how could you actually just project it as a sound? Then there would be anyway a black screen. So I just thought about that. And then, of course, I couldn't help except to catch the word catastrophe. And because I follow, I realize most of my work somehow comes from the everyday life and, of course, the current kind of a catastrophe and the war. And I was actually thinking, is there some kind of system that you could, of course there is, in kind of depicting sound from somehow like a normal situation? Because I know you can create and gather all kinds of data, but how would it be created in sound and from where? Some kind of a normality and juxtaposing kind of catastrophe in sound, and how could that be depicted? I mean, in a mathematical formula, or I don't know. I was always in math. I always tried to find my own formulas. I was too difficult to use the given formula, so I always try to somehow get my own coding or my own, not code, but my own way of understanding. But how could it like sound depict this kind of catastrophe? Yeah, and I was thinking of the many things that are kind of raised in my mind, but also the abstraction of meaning, kind of the no visualization at all linked to sound. So really, really interesting and inspiring for me as a visual artist, working with text, but trying to kind of get away from the meanings of the concepts of. I'm actually trying to get to kind of where you are, because I'm trying to abstract words so I don't have to refer, because they actually mean nothing anymore. The words but they always catch people. So I'm trying to get to that abstract place. I guess what I'm asking the question about. Yeah, a very long question comment. So thank you very much. Super interesting.
Yeah, there's a lot in your question, in your comment. Yeah, I think there is something that resonates with me as being like, I mean, we are not. I think for us, it's not really meaning in that way, but there is something obvious. I mean, there is something in the visual, or in combining the visual with the audible that gives rise to another level of meaning that we don't really intend. I mean, it's a completely unintentional kind of meaning. I think it's a more experimental thing that we really don't know what comes out. We have this method, we have this way of inspecting the sound almost, that gives us something sorry, that gives us like another tool of understanding how our sounds relate to each other, and in that sense there is a meaning. There's a meaning if there's a stable pattern, there's a meaning if there's something that is maybe a very rounded shape or a kind of an edgy shape, like at which time scales things maybe relate to each other, or if there's no relation, if it gets very blurry, noisy, then obviously there's very little relation maybe. But there's also more meaning that we don't intend it. So it becomes a kind of a machine that creates somehow meaning, or that just like adds things together that then give rise to meaning that we haven't really intended. But I think that's also what is interesting for us, as not being actually visual artists, but as kind of having that other kind of medium in there, and seeing how it changes also how we hear, how we listen. And I think that's probably more what we actually strive for, like how it changes the listening and how it changes the playing for us as it becomes.
So it becomes visual once it is visual, whether it's intentional, because there are many from the visual arts. There's a lot of like kind of experimental arts, experimental use of visualization that is purely, or like Dadaists say, just took matters and appropriated texts from different places. So it kind of overlaps with that kind of anything that you bring into visual, whether it's an intentional or not. It is a different kind of level of interaction. So
Yeah.
I think that's very interesting.
Yeah.
What about the catastrophe part? What kind of how would catastrophe sound from a mathematical perspective?
I don't know how it would sound. I mean, there's obviously this term catastrophe, but it's maybe not the same thing necessarily as a catastrophe as we think of it in different realms. But yeah, I mean, what David described as this kind of something that is close to being noise, like close to being totally chaotic, but then also between a kind of pattern, a stability, and something unstable. I think that's where we always kind of try to be in sound, that there is this, that we are at the verge of something turning to chaos, turning to something that doesn't really display any pattern anymore, and to see how some kind of pattern emerges again out of it. And that kind of in-between zone, I think, is what we, or that also that's, I think, a kind of fragile situation, that something is kind of sensitive in a way that if something happens, it could turn to complete chaos, or it could turn back into a pattern because it is sensitive to these kinds of repetitions that are there, maybe, or certain kinds of stabilities. Yeah, I mean, what David described as this kind of something that is close to being noise, like close to being totally chaotic, but then also between a kind of pattern, a stability, and something unstable. I think that's where we always kind of try to be in sound, that there is this, that we are at the verge of something turning to chaos, or it could turn to complete chaos, or it could turn back into a pattern because it is sensitive to these kinds of repetitions that are there, maybe, or certain kinds of stabilities. Yeah, I think that's maybe how I would think of it. I mean, there's a completely different. I don't know, when you were talking about the war and sound there, I don't know. There's a completely different type of level of meaning to these sort of catastrophes. I think that are for me a little bit harder to relate to how we think about it. But there is obviously obviously some sort of relation, but it's much harder to spell out for me.
I guess I was wondering about the kind of the formula for catastrophe in code in the language. Is there a similarity there potentially? Like kind of equations in physics or in math and sound, because that's an area I don't know that much. That I'm just wondering, is there some kind of formula for that catastrophe that you could, you can create a formula for, and this is what catastrophe sounds like. I guess that's what I'm trying to look for.
I mean, in terms of dynamical systems, the catastrophe is when something happens which is sudden and from which you can't really get back from where you were before. And this is a catastrophe because anything in mathematics or in physics usually is very smooth, or at least to some extent smooth, meaning that there is always a path that goes from one point to the other, and that path is in some relationship to the path you took to getting there. And but there are some systems that are, even if they are smooth and even if they are in their formulations are very, so to say, nice, they exhibit this catastrophe patterns, meaning that they really have points there. If you depict if you may depict the behavior of that system as a sort of a space, there is a cliff. There is a point where something changes abruptly, and that is a catastrophe for physicians because nothing is smooth anymore, or for mathematicians, because there is a cliff and there is a discontinuity, and that is really hard to come by with. And so catastrophe in that sense is something that is sudden and that is almost unforeseeable from what you had before. And I think what Luc said before is very apt. So probably for us, this kind of moments in which things switch or go from one, almost very abruptly go from one situation, from one behavior into a completely different one. These are for us very interesting spaces, temporal spaces and moments. Maybe these are catastrophes for somebody else. For us, these are the most important, most interesting spaces to move in. So I don't know if that answers your question in any way, but
yeah, it makes sense if I'm trying to make sense out of it. Yeah.
You have these great weather models where sometimes they are very predictable, but then they go into a certain thing and it's almost like an opaque wall, and after that it feathers out, so it's like you cannot see beyond that point. It's almost like a strange property of these complexly connected systems.
Yeah,
sorry. No, you go ahead.
I mean, just as a kind of side note, like I'm just trying to relate it back to also what Nina said with like catastrophes in what social or whatever, biological, environmental and political catastrophes, that there is of course also something maybe different, which is like it's not necessarily a lack of knowledge. Like global warming is we have known about that catastrophe and we are still steering towards that catastrophe, fully knowing about it. And even though it may have very abrupt and sort of riff or cliff-like effects, we know about it. And there are many, most of these catastrophes are in a way known in advance in some form or steered towards in advance. And I think that makes it, I'm just trying I guess I'm struggling to relate it a bit to what we do.
Yeah, I actually see, I think I understand what you mean, because these are predictable, like in essence, some things, they're predictable, they've been there. So human knowledge, trying to understand and make logic about it when they were known already long time ago. So I actually see now what you mean with your, I understand actually better. Yeah, that makes it clear. Yeah.
So I don't really want to even give them sort of the aesthetic value that we attribute to the kind of catastrophes that we use in our work. I think these are much more stupid catastrophes in some level.
Maybe I just want to mention, maybe it's not even a question, it's just a comment that so for me it's very difficult to reconcile the concept of catastrophe or with these type of art form where, with these type of artistic discourses are more pointing towards a type of meaning which is related to like a much, you call it, like a sort of lower level perceptual kind of reception of a message. So you're more dealing with the recognition of patterns, and it's more like a kind of like a gestaltic sort of meaning in a way. It's completely out of any sort of reference as it's, you could call it abstract or anything, but I guess if it's a catastrophe, it's a huge cultural concept, and I guess there's a huge leap between these type of discourse and that idea of catastrophe. I mean, it's I don't know, it's like a big jump. I don't know. It's but I guess maybe just to wrap up the comments, the type of meaning that the idea of meaning that I get out of this type of narrativity is, like related to a more sort of basic mechanisms of grouping, segregation, continuity, and those kind of things that are explained by the Gestalt theories and, auditory scene analysis, maybe. Yeah.
But like Gestalt is also in visual arts, it's actually laying out things, and by positioning, because my background is in book design and typography, there in like Gestalt comes from putting certain patterns, repeatedly on similar places, and so there I see similarity still in like that kind of a laying out of things. And there also the catastrophe means that something slips out or doesn't actually belong to that place, and there is actually a clear kind of rule, like scientifically, for example, what is the formula to create a kind of perfect book or perfect page? And that's been repeated, of course, by human beings for the past 500 years. And so it's a different type of world, but they somehow, I see the relation even mathematically, because I used to calculate margins and actually page layout, millimeters, which goes where, kind of learning, which is like a science of a book, but then creating that towards a more artistic form. And there the Gestalt actually is pushed around because new elements are introduced, and the kind of catastrophe is when the things don't work in the like previously they did. So the code is broken. So that's why I see that kind of a similarity. And when there's silence, it's an empty page, like now.
No, I'm sorry, but I will have to go in very shortly. I mean, it's already 6:30. if there are not any urgent questions, I would then call
To
it
me,
as.
to me, it's very interesting. I mean, I would ask if I would spend a lot of longer time discussing it, but I know it's, there's a time limitation, but yeah, it's really interesting work. Thank you.
Thank you. I mean, there will be other occasions to discuss and work with. I mean, this is.
I hope that we can also find some kind of form of meeting, like physically at some SAR conference or some other occasion like that. I'm sure there's going to be something in the next months or so.
Yeah.
Casper transformed into a cat.
He tends to do that.
That was quick.
I need to go, so thank
Yeah.
you.
Yeah. Thank you very much. I need to also go.
Same
Thank you.
here.
Wonderful.
Thank you very much for the performance and the discussion, and
Thank
Yes.
you.
see you next
Very
time.
interesting.
Bye bye. Thank you.
Thank you.
Thanks.
Bye bye.
See you around.
Bye.